Welcome to IIT PAL program. We will continue the chapter aldehydes, ketones and carboxylic acid. Today first we will talk about the structure of the carbonyl group. So, as you can see that carbon is 2s2 2p2 hybridized, and in carbonyl group carbon is sp2 hybridized. So, in sp2 hybridization, as you can see in the ground state there are 2 s electron and 2 p electrons, and in the excited states one electron jumps from s orbital to p orbital, and after that hybridization occurs. So, each sp2 orbital gets 1 electron and unhybridized p orbital gets 1 electron. So, these sp2 orbitals form sigma bonds, whereas the unhybridized p orbitals makes the pi bonds, and this pi bonds happens with the oxygen atom with the p orbital of the oxygen atom, where also 1 electron resides, and eventually the oxygen atom also is sp2 hybridized. So, all these 3 sigma bonds stay in the one plane, and that is why these atoms attached to the carbon atom also are coplanar, and this geometry is called trigonal coplanar, and the pi electron cloud resides above and below the plane. So, now we will discuss about the polarity of the carbonyl group. So, in carbonyl group, since oxygen is electronegative than carbon, there is a delta minus in the oxygen atom and delta plus charge in the carbon atom. So, what happens? This is since there is a excess of electrons, this oxygen atom is nucleophilic center and it can act as a Lewis base, and this carbon atom is electrophilic center and can act as a Lewis acid center. Also, there is a dipolar resonating structure which explains that carbonyl high polarity which explains the high polarity of the carbonyl group. Now, we will talk general procedure for the synthesis of aldehydes and ketones. So, first one is the oxidation. Oxidation of alcohols. And this oxidation has been extensively discussed in unit 11. So, here the primary alcohols on oxidation gives aldehydes. and secondary alcohols and there are variety of reagents which acts as oxidizing agents for this kind of oxidation. PCC, pyridinium chlorochromate, and chromium trioxide in mineral acid or medium acid. This is selective reagent for oxidation of alcohol to aldehydes, so that further oxidation of aldehyde does not happen. The second procedure is the dehydrogenation of alcohols. So, this is an industrial method and suitable for volatile alcohols. And in this process, the alcohols are passed through the silver or copper catalyst. Another important method is the form hydrocarbons. And the first method is the ozonolysis. This also has been discussed in unit 13. So, in ozonolysis what happens, an alkene on reductive, after treatment with ozone and a reductive workup gives two carbonyl compounds. Here you can get, depending on the substituents, either two aldehydes or two ketones or mixture of aldehydes and ketones. Another method is the from alkynes. So, here in alkyne, if it is acetylene, acetylene only gives acetaldehyde, but any other alkyne, terminal alkyne or internal alkyne, whatever, it will give the ketone. This also has been discussed, I think, unit 13 class 12. So, we will discuss some special preparation of aldehydes. And first we will discuss from acyl chloride. This is a name reaction which is Rosenmund reaction. And it has been discovered in 1918. So, here this acid chloride is used which is selectively reduced to aldehyde. Here barium sulphate is very important. Because it has a low surface area, it reduces the activity of palladium. Also, for some reactive acid chloride to reduce further the activity of palladium, some poisons like thiourea, quinoline, etc. are used. Nitriles are very important starting material for the synthesis of aldehyde and ketones. We will first discuss the synthesis of aldehydes. So, here mild reduction happens. With SnCl2 and HCl, the iminium ion is formed, and which hydrolyzed on hydrolysis give aldehydes. This is a name reaction. This is called Stephen reaction. Another procedure from nitriles is there. The full name of DIBAL-H is diisobutyl aluminum hydride, and the structure is so two isobutyl group are attached to the aluminum, and there is only single hydrogen. So that is why it is milder than lithium aluminum hydride. But it is stronger than sodium borohydride. What will happen if you put one equivalent of DIBAL-H to nitriles? This imine is formed, aldimine, and this on hydrolysis give the aldehydes. This is an important synthesis, because if you have a alpha beta unsaturated nitriles, this also selectively gives the aldehydes. There is no reduction of the double bond. Esters can also be used for the reduction using DIBAL-H, and that also gives aldehydes. But under special condition, what is the special condition? One equivalent DIBAL-H you have to use, and toluene is the generally the solvent of choice here. Because if you use at room temperature, then you will get some alcohol. So what happens if you add one equivalent DIBAL-H this intermediate forms, only one hydride delivery takes place, and this is stable at low temperature. And on hydrolysis, this compound so only on hydrolysis only the aldehydes it forms, because if you use excess hydride, then this OR will come out and then you will get the alcohol. So, we will discuss now special preparation of aromatic aldehydes. So, methyl benzene can be oxidized to aromatic aldehydes, and this can be done by two ways. First one, chromium trioxide and acetic anhydride mixture. So, the first one we will discuss first, oxidation with chromous chloride. So, here what happens, if you put methyl benzene like toluene here, in presence of carbon disulfide, you get benzaldehyde. And what is the mechanism? So, this is called in reaction. First step may be in reaction. So, in reaction like this, the double bond forms here, and then this one, and then a Cl minus can come. There are two possibilities, either again this sequence happens, that is the in and 2,3 sigma tropic with another chromoschloride, and then you can get this compound. And this on hydrolysis give you aldehyde. Alternatively, we can think that the Cl minus can deprotonate this and you can get directly aldehyde. So, either possibility may happen. So, chromium trioxide acidic anhydride also a good reagent for the oxidation of methyl benzene to benzaldehyde derivatives. And the intermediate are believed to be similar like chromoschloride reaction, that this intermediate is formed, which on hydrolysis gives aldehyde. So, chromium trioxide in acetic acid, in acidic anhydride, chromyl acetate, this forms. And this is the active reagent which reacts and maybe similar mechanism like in reaction and rearrangement, like previous reaction, this happens. The second procedure is the so, here also methyl benzenes are used. And chlorine in presence of light benzyl chloride, this is formed. And this on hydrolysis give benzaldehyde. So, this is very important, this is side chain chlorination. If you put chlorine and any other Lewis acid, then the chlorination will happen in the chain. So, for selective chlorination on the methyl group, you have to put this UV light, and so that the radical method, the chlorination will happen. Benzenes can also be used for the synthesis of aromatic aldehydes. And there are various methods. We will discuss mainly two methods. First one is the Gatterman-Koch. So, what is that? Koch. In this carbon monoxide and HCl is used. Another method we will discuss little bit, which is called Vilsmeier-Haack. Here POCl3 DMF. So, for benzene it is understood that you have to bring one more carbon atom, and this single carbon unit like POCl3 or the DMF that takes part in this kind of reaction. So, first we will discuss Gatterman-Koch reaction. And here you have to put some catalyst also, anhydrous AlCl3. So, this is Friedel-Crafts type reaction, and this is as I told you previous slide that Lewis acid has been used if you want to functionalize the benzene ring. So, here this catalyst helps in the Friedel-Crafts reaction. So, what is the mechanism of this reaction? So, carbon monoxide can be drawn like this. And then so, this is the active reagent that is generated from AlCl3 and HCl from carbon monoxide, and this then does the Friedel-Crafts reaction. So, Friedel-Crafts reaction mechanism is that this kind of and then minus H plus will give you the product. Next we will discuss Vilsmeier-Haack reaction. And here the reagents are POCl3 and DMF. So, if you mix POCl3 and DMF, this species forms and this is the active reagent which takes part in the Friedel-Crafts reaction. So, first this have forms and then iminium ion generated, and iminium ion on hydrolysis gives aldehyde. So, we will discuss special preparation of ketones. So, first one from nitriles or from acid chloride, sorry, first one from acid chloride. So, earlier we have seen acid chloride can be synthesized, can be used for the synthesis of aldehydes. So, here we will see that acid chloride will be used for the synthesis of ketones, and here Grignard reagent generally used, and with cadmium chloride. So, cadmium R2 cadmium is the active species here. So, what happens? First step is the 2R NGX. This is Grignard reagent. And then acid chloride So, this R2 cadmium then reacts with the acid chloride, and R2 cadmium is milder than Grignard reagent. so that it stays in the ketone. Otherwise tertiary alcohol, if you treat with acid chloride with Gigner reagent, you get tertiary alcohol. And earlier I told that nitriles can be used also for the synthesis of ketones. So, we will discuss now. And here always you need another group like R. Here also nitriles, also you have to bring another group like R, and that can be Gignered, and you can get the ketones then. And this is here ketamine. So, earlier aldimine was formed, now it is ketamine. So, ketamine is formed, and ketamine on hydrolysis gives ketones. And last one we will discuss, that is from benzene. So, from benzene we have previously seen synthesis of aldehydes, benzaldehydes or aromatic aldehydes. Now, we will see synthesis of ketones. So, for the synthesis of ketones, you can do Friedel-Crafts reaction with acid chloride it can be aliphatic acid chloride or aromatic acid chloride, and in presence of catalyst anhydrous aluminum chloride, you get the ketone. So, this is Friedel-Crafts reaction. So, this is a powerful reaction to get different aromatic compounds. And now we will conclude here the synthesis part.